to me, it's very good to talk about anomaly detection and pattern recognition because we are using those techniques to tackle problems into the monitoring tribe. Before talking about the techniques and the theory behind the anomaly detections, let me ask you, imagine a case scenario in which you are about to flight, you have already checked in, you are onboarded in the airplane, and the last thing I'm sure you want to happen is a failure in the system or somehow in the engine, or even worse, a catastrophic failure or an accident afterwards, right? Airplanes and airlines, they use sensors data to monitor how their fleet are performing prior to any travel, and they want to detect any kind of failure prior to their occurrences. We are trying to use the same kind of approach in our internal systems. You can use anomaly detection algorithms to detect intrusion into the networks and also detect an energy leakage into smart houses and using IoT data, and also healthcare systems to detect fraud in payment and other things, to detect and also to predict, and also into the manufacturing and so on and so forth. On my previous experience, I'm going to cite two examples that I'm just showing here for transportation and finance. When I was into the engineering school, I participated in a robotics competition called IGVC, which stands for Intelligent Ground Vehicle Competition. You had an autonomous robot to detect the lines by itself, and also based on the GPS location it has to drive without any intervention of the user and also the controller. And here you can see some of the pictures, and it's a very good example how pattern recognition is used today for robotics companies to have autonomous kind of vehicle without the human intervention, using machine learning to apply intelligence and recognizes the behavior. The other experience is my first internship. It was at Magna. Magna is a supplier for the OEMs, the manufacturers for the auto industry. They have a lot of already advanced driving technologies, and they are integrating all of them to provide a self-driving, autonomous self-driving experience to the users. And they use a lot of sensors, the surround view cameras and then cross traffic view, and also some automated parking control system technology to do those kind of capabilities. And for the traffic jam assist, they use machine learning algorithms to recognize the pattern and also process object to detect whether it's a pedestrian, it's a car, or it's a fixed vehicle object into the road, and it has to deviate. And it uses a lot of sensors information to provide this capability to the driver. And my last experience, the iFood company is a startup. They are one of the first unicorns, a startup that reached more than 1 billion reals in the last very short time. They are using machine learning to detect fraud and also recommend products to the users. And we used more than 15 million credit card transactions, and also the chargeback data set that we had based on previous frauds that they had registered, to see anomalous data that represented frauds and all possible frauds based on credit card transaction, previous purchase, and also the profile analysis of the users. I brought you some examples outside in the real world and the experiences I had, but let's think about IBM, and especially at the monitoring tribe.